Question number 31. Which of the following statements are true regarding electrochemical reactions and electrode potentials? Statement A. Electrode potential is an intensive property. This statement is true because electron potential does not increase even if the amount is increased. Statement B. Half-cell reactions are reversible. Statement B is also true. When the direction of the current is reversed, a backward reaction takes place. Statement C. Standard electrode potential changes its sign for the reverse reaction. This is true. If we take the zinc electrode as an example, if the forward reaction is negative 0.76 volts, then the backward reaction has the positive value of the same amount. Statement D. Electrode potentials are independent of the temperature. That is false. Electrode potential decreases when the temperature is increased. Therefore, we have true, true, true and false, which gives us the answer number 5. Question number 32. Which of the following statements are true regarding compound A? Statement A. A forms an aldehyde upon treatment with diluted sulfuric acid in the presence of G.C.E.A. This is false. According to Markovnikov's rule, H binds to the carbon with high number of hydrogens. Therefore, it will bind to the terminal carbon and oxygen to the next carbon, giving us a ketone. In this reaction, diluted sulfuric acid acts as the H plus donor to this electrophilic addition reaction, and HgCl2 is sort of a helping hand to this reaction. So statement A is false. Statement B. A liberates H2 when reacted with sodium. This statement is true because sodium displaces the H of the terminal carbon, which forms the triple bond, giving us H2. This is an electrophilic substitution reaction. Statement C. A liberates N2 when reacted with sodium nitrite with aqueous HCl. This statement is also true. This reaction will convert the NH2 into a hydroxyl group, emitting N2 and giving us sodium chloride and water. Statement D. A liberates carbon dioxide when treated with aqueous sodium bicarbonate. This is false because alkynes are not acidic enough to react with sodium bicarbonate and give carbon dioxide. So statement B and C are true, therefore giving us the answer number 2. Question number 33. Which of the following statements are true regarding polymers, polystyrene, polyvinyl chloride, phenol formaldehyde, and nylon? Statement A. Only polystyrene and polyvinyl chloride are thermoplastic polymers. Well, this is false. Thermoplastic polymers are polymers of which the shape can be altered by applying heat. So nylon is also a thermoplastic polymer in this case. Statement B. Only polystyrene, polyvinyl chloride, and nylon are thermosetting polymers. That is also false. Thermosetting polymers are polymers of which the shape cannot be altered by heating. Polythene, polystyrene, and nylon are thermoplastic. Statement C. Only phenol formaldehyde and nylon are prepared by condensation polymerization. That is true. Condensation polymerization is basically joining two monomers by removing another molecule like water. Statement D. Only polystyrene, polyvinyl chloride, and nylon are prepared by condensation polymerization. Well, it is false because in C we said only phenol formaldehyde and nylon are, and that was true. So in this case, polystyrene and polyvinyl chloride are formed by addition polymerization. So in these images you can see polystyrene and polyvinyl chloride are formed by addition polymerization, and phenol formaldehyde and nylon 6,6 are formed by condensation polymerization. In these two condensations, H2O is released. So now because only C is true, the answer is 5. Question number 34. Which of the following statements are true regarding natural rubber? Statement A. The relative molecular mass of the natural rubber is around 750,000. That's true. Statement B. Ebonite is formed when natural rubber is heated with a large amount of sulfur. That's true. The amount of sulfur used is 25 to 30%. Statement C. Although cis and trans isomers are possible in natural rubber, due to presence of double bonds, natural rubber has a trans configuration. That is false. It's a cis polyisoprene. Statement D. Vulcanization of natural rubber reduces its hardness. This is false. Vulcanization of rubber is done by heating it with 1 to 3% of sulfur at 373 to 450 Kelvin temperature. This results in the increase of hardness of rubber. So statement A and B are true, C and D are false, so the answer is 1. Question number 35. An ideal solution is prepared by mixing two miscible pure liquids. Which of the following statements are true regarding the above? Statement A. The enthalpy change during mixing is 0. That is true. When an ideal solution is formed by mixing two miscible liquids, the energy of the intermolecular bonds that are broken will be equal to the energy of the newly formed intermolecular bonds. Therefore, there will be no enthalpy change. Statement B. Raoult's law cannot be applied to the above ideal solution. That is false. Raoult's law is valid for any ideal solution. Statement C. The vapor pressure of the solution is equal to the sum of the partial pressures of the two liquids. That is true. Statement D. The vapor pressure of the solution varies linearly with the mole fraction of each of the liquids. That's true. So related to the D statement, the linear increase or linear change can be clearly shown in this graph. And statement D is easy because P equals PA plus PB. Here's Raoult's law and a little bit of simplification to refreshen your memory. So A, C and D are true. The answer is 5. Question number 36. When one of the enantiomers of A, enantiomers are two optically active molecules which are mirror images of each other. An optical isomer has an asymmetric carbon atom, which is called a chiral carbon. In the compound given in A, the carbon here is asymmetric. Therefore, this molecule is optically active. Statement A. Is treated with zinc, mercury, and concentrated HCl, the product does not show optical activity. In this reaction, the aldehyde group is converted to a CH3 group. Therefore, this carbon will have two CH3 groups, which makes the molecule no longer asymmetrical. This statement is true. Statement B. is treated with lithium aluminium hydride, the product does not show optical activity. Here, the aldehyde group is converted to alcohol, CH2OH to be precise. Therefore, the carbon remains asymmetrical and will show optical activity. Therefore, this is false. Statement C is treated with ammoniacal silver nitrate. The product does not show optical activity. Ammoniacal silver nitrate is Tollens reagent, which is used to differentiate aldehydes from ketones. Tollens reagent is a weak oxidizing agent. It oxidizes the aldehyde to COO- NH4+, and silver is deposited. This reagent also reacts with the alkyne group, replacing the H with silver, and the product will precipitate. The chiral carbon remains asymmetrical and therefore will show optical activity. So this statement is false as well. Statement D is treated with hydrogen palladium. The product does not show optical activity. H2 palladium is a hydrogenating agent in which palladium is the catalyst. Palladium is a weak catalyst, but its activity is enough to hydrogenate the alkyne group, forming CH2CH3. Hydrogen and palladium can also hydrogenate the aldehyde group to CH2OH, although in small amounts. The carbon now loses its asymmetry and will become optically inactive. Therefore, this statement is true. So, statement A and D are true and the answer is 4. Question number 37. Compound B was heated with aqueous sodium hydroxide and the cooled reaction mixture was neutralized. When bromine water was added to the reaction mixture, it was decolorized. According to this observation, which of the following compounds could be B? Let's first look at the products of these compounds. So A and B products have COOH group attached to the benzene ring, whereas C has an NH2, which means it's an aniline, and then D has an OH group, which means it's a phenol. COOH group is a deactivator of the benzene ring, whereas NH2 and hydroxyl groups are activators, more specifically orthopara activators. If we move on to the second part of the question, they say that bromine water was decolorized by the product of this compound. Decolorization of bromine happens due to an electrophilic substitution reaction. It easily happens in an activated benzene ring. In A and B, the ring is deactivated, but in C and D, the ring is highly activated. Therefore, C and D will decolorize bromine, whereas A and B will not. In this case, since the para position is occupied by CH3, bromine will bind to the ortho position. So the end products of C and D will form a white precipitate. Therefore, the answer should be C and D, which is answer number 3. Question number 38. Which of the following statements are true regarding equilibrium systems? Statement A. The unit of the equilibrium constant of a chemical reaction can be deduced from the balanced chemical equation. It is true. Here's an example. And after you simplify this, you get the unit of this constant. Statement B. Equilibrium constant of both exothermic and endothermic reactions change with temperature. This is true. It is dependent on the temperature. Statement C. Both gas phase and liquid phase chemical reactions can reach equilibrium in an open system. It's false. The concentration of the constituents of an open system changes with time. For a system to arrive at equilibrium, its constituents have to remain within the system with a steady concentration. Statement D. If an equilibrium reaction can be expressed as the sum of two or more equilibrium reactions, the equilibrium constant for the overall reaction is given by the sum of the equilibrium constants of the individual reactions. This is also false. Sometimes they have to be multiplied. So only A and B are true, giving us the answer 1. Question number 39. Which of the following statements are true regarding ammonia? Statement A. Ammonia can act as both an oxidizing agent and a reducing agent. This is true. Nitrogen in ammonia has a -3 oxidation state. This is the lowest oxidation state of nitrogen. Therefore, it can be oxidized. The example given is ammonia reacting with chlorine gas, giving nitrogen gas and ammonium chloride. Here, ammonia acts as a reducing agent by reducing chlorine from a 0 oxidation state to -1. The nitrogen atom in ammonia gets oxidized from -3 to 0 to form nitrogen gas. Ammonia plus sodium giving sodiamide plus hydrogen is an example for ammonia acting as an oxidizing agent. Here, the H in ammonia undergoes reduction from +1 to 0, oxidizing sodium from 0 to +1. For this reaction, liquid ammonia has to be used to prevent the reaction of sodium with water forming sodium hydroxide. Therefore, this statement is true. Ammonia is produced in large scale using the Haber process, where nitrogen and hydrogen gases react with each other under a pressure of 200 to 300 atm at around 450 to 500 degrees Celsius to produce ammonia in the presence of iron and its oxides as catalysts. As there are 4 molecules on the left-hand side and 2 molecules on the right-hand side, according to Le Chatelier's principle, increase in pressure causes the reaction to shift to the right. As this is an exothermic reaction, maximum percentage of products formed is at lower temperatures, but the production rate is much slower. As rate of reaction increases with increase in temperature, the temperature is maintained at a moderate level. Therefore, the answer is false, as high temperatures are not used. Statement C. When ammonia reacts with excess chlorine gas, the products are N2O and HCl. Here is the reaction. It is false because nitrogen is formed and then ammonium chloride is also formed. So this statement is false. Statement D. Ammonia is used in the rubber industry to prevent premature coagulation of latex. It's true. Rubber particles are mostly negatively charged, so they naturally repel each other and prevent aggregation. But carboxylic acid produced by bacterial action neutralizes the negative charge on rubber, which will promote coagulation. This can be avoided by adding ammonia, which will neutralize the H+ in carboxylic acid and prevent clot formation. So A and D are true, giving us answer 4. Question number 40. The only group 1A element to react with nitrogen gas is lithium. In an experiment, 51 grams of lithium is allowed to react with 39 grams of nitrogen. Which of the following statements are true? So this is the calculation First we have to write down the proper balanced reaction. And then we can see the lithium to nitrogen ratio is 6:1. Then we should find the moles that are given to us. So the number of lithium moles is 7.286 and nitrogen 1.393. Now we have to see what the ratio between those two moles is. When we divide both of these numbers with 1.393, we get lithium 5.23 to nitrogen 1, which means there is a nitrogen excess. So statement A, lithium will react completely and some nitrogen will remain, is true. And statement B, which contradicts statement A, saying nitrogen will react completely and some lithium will remain, is false. Making statement C, which says neither lithium nor nitrogen will react completely, false. Statement D, theoretically, the amount of product formed will be 85 grams. Now we have to calculate the mass of lithium nitride. We have the number of lithium moles which entirely reacted with nitrogen. So it will comply with the ratio. We can't use the number of moles of nitrogen because nitrogen is in excess here. If we calculate the mass now, we get 85 grams. So statement D is true. The answer to question number 40 is 4 because A and D are true.
Hey guys, if you liked our videos, please like, subscribe and turn on notifications. Thank you.